interface. Okay, so it is also a communication protocol which is used by many different devices, such as the SD cards. You might have heard RFID card reader modules, and wireless transmitter receivers uh, to interact with microcontrollers. Okay, so SPI was developed by Motorola in the mid 1980s, and they are currently used for communicating with one or more peripheral devices, mainly for short distance. Okay. Then SPI is actually full duplex. You know what is the meaning of full duplex, right? You can transmit and receive at the same time. Also, it uses a 4-wire. Okay, it has a clock, then transmitting, then there is a receiving, and also a pin for selecting the chip. So there are only 4 wires that is required. So it is also known as a 4-wire interface. Okay. And the applications include. Now the applications include. They are used for MMCs, SD card. Then they are used in DACs, ADCs, also audio and video codecs, digital potential meters, flash memories. They are used in Canon EF lens, also used in real-time clocks, LCD and LED. Then maybe used in video games, Ethernet, USB, USART, CAN. Okay, so for all these, you can use SPI as an application. Okay. Now, one main benefit of this particular SPI is data can be transferred without any interruption. Okay. Now, any number of bits can be sent or received in a continuous stream. No, but when things like UART is limited to 8 bits. You will see I square C. I square C is also limited. There is a number of data packets that is limited. Okay. So the data can be transmitted without any interruption in the case of your SPI. But here, devices usually can communicate in the form of a master-slave relationship. That is, there's a one person who is controlling the device, which usually it is a microcontroller. Then we have devices that is connected across, which is driven. Maybe slaves. They are known as slaves. Maybe you can say as a sensor or a display or a memory chip, something like that. Okay, which takes instruction from the master, or it may request the master to it requires a resource of the master. Okay. Now, the simplest configuration that you can think about is a single master, a single slave system, but master can control more than one slave. Okay. So mainly it has 4 signals, as we discussed before, 4-wire interface. It has a clock, there's a chip select, there is a master out, slave in, which means that the master is transmitting the data. That from that pin only the master is transmitting the data. Then also there is a MISO pin, which is master and slave out, where the data from the slave is read in. Okay. So this is a configuration diagram, how it is connected. Now this diagram indicates it is a single master, single slave, where you can see CS indicates the chip select, CS bar. It is an active low. Okay. So when the transmission is not there, always the line is a high. Now when there is a connection to be established, it indicates that the line will go to an active low. Then there is a clock for the synchronization. Then you have MOSI and MISO pins for data in and data out. Okay. Now, how it works? Now, this configuration is how you connect a multiple slave single master configuration, where you can see, these masters can have multiple chip selects or single chip selects. Now, in this particular diagram, you can see there are multiple chip selects. Say you have n slaves connected and you have n select lines. The slave which you need to interact with, that line will go to an active low, and the corresponding line at the master. Whether if you say, for example, you are talking about SS1, SS1 ആണെങ്കിൽ അതിന്റെ അർത്ഥം എന്ന് slave 1 ആണ്. Slave 1 communicate ചെയ്യണമെങ്കിൽ its SS will go to an active low and the SS1 will go to a low, so that there is a connection established. Okay. So usually you say the configuration is like a daisy chain. Daisy chain എന്ന് പറയുമ്പോഴത്തേക്ക് നമ്മുടെ ഒരു ഗാർലാൻഡ് പോലെ അങ്ങനെയാകാം. അപ്പോൾ അതിനകത്ത് 2 രീതിയുണ്ട്. There are 2 methods. So one is like you can have a linear way. Linear way എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ you have the master is connected to the slave 1 directly. Slave 1 is connected to the slave 2, and slave 2 is connected to slave 3. Now, if you want to add another one, you will add at the end of the slave 4. So that is a linear type. So അവിടെ പ്രശ്നം എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഏതെങ്കിലും ഒരിടത്ത് കമ്മ്യൂണിക്കേഷൻ കട്ടായി കഴിഞ്ഞാൽ slave 1 ഇടയ്ക്ക് കമ്മ്യൂണിക്കേഷൻ കട്ടായി കഴിഞ്ഞാൽ what happens? The slave 2 and 3 will not be getting the data. Okay. കാരണം ഇപ്പോൾ slave 3 data ആവശ്യമുള്ളതെങ്കിൽ what happens? It has to pass via the slave 1 and 2, right? So that is the problem. Now, another method is a ring type, where it is connected as a circular topology, where data can go either way. So if right hand side communication it can go via the left hand side, and maybe the communication can be established to except the one which has a defect. Clear? So next is the steps in transmission. Okay. Now the first, what is done is the master outputs a clock signal. Okay. Now, once it outputs a clock signal, if it wants to communicate, it activates the slave by sending an active low. Okay, by sending an active low, which activates the slave. Then it sends data 1 bit at a time along the slave through the MOSI line. Okay, through the MOSI line, and the slave reads the bit as they are received. Okay, now you can see the diagram. MSB is sent first. Okay, now vice versa, if the slave is communicating, same way, the data is sent via the MOSI pin or the serial data output pin of the slave. Okay. And it is received at the MOSI pin, but there the LSB is transmitted first. Here. Now, the advantages of SPI are, it is simple. Okay. It uses only small amounts of data. It is used only when we require small amount of data to be sent. And also, as you can see, the circuitry, it is very less complex. It has less cost, and also it is synchronous because there is a clock present. Disadvantages with respect to your USB, the current upcoming trends, the current USB, Ethernet, Bluetooth, Wi-Fi, it is comparatively slower.